Hey guys, it's your friendly neighborhood math teacher here. Obviously I am not here today. I am in Des Moines at a conference, and I wanted to make sure that you knew exactly what was going on in class. Not that our sub can't teach math, but I really wasn't sure who I was going to get for a sub. So just in case, I wanted you to be able to hear things from me, and that way you're not kind of lost about what's going on. Now we're going to have to work a little quick because I know that we have a short class today. I know you're really excited about that. So just kind of pay attention if you would. Take notes as we go, and there will be times that I ask you to pause the video and work a few problems. So pause it, work a few problems, check your answers. This video is going to stay on Canvas for a little while, so if you need to go through things over the weekend or listen to things again if you run out of time, go right ahead. But try not to waste too much time today, and that way if you're going through and listening to this and you have questions, you can maybe talk to somebody in class who's listening to the same thing, and they can go, oh yeah, do this way. Anyway, so here we go. We're starting chapter 2, so if you want to go write on your notes chapter 2 just in case. You can see that we're going to work on more functions, this time a lot about polynomial functions, not just linear things. We've done a lot of lines and parabolas. Now we're going to get into some crazy things too. Here we go. Okay, so something that we have talked a little tiny bit about in the last chapter is to know sort of what these functions look like. If you have a general idea of what these functions look like, that's going to help. So get your notes all ready, and here are some vocabulary words that you are going to need to know. So looking at some different kinds of functions. Our very first kind is a constant function, and a constant function is when its y equals a constant number, like y equals 2, or y equals 3, or y equals -6. You know what those functions look like, right? So let's go take notes on constant functions. So a sample equation could be y equals 2. And you know that when you sketch that, that's just a nice horizontal line. And if you're asking about the degree of it, that's the degree of the x variable. And there's no x there at all, so we say that has a degree of 0. Okay. Next is a linear function. You've done linear functions for forever, right? So linear functions can go up, they can go down. You know linear functions, y equals x plus 6, y equals 1/4 x minus 3, y equals -2/3 x minus 18, whatever. And if we're talking about degree, that's the degree, the exponent of the highest power, and that's just a 1. We just have x to the first, so it's just degree 1. Okay. Next are quadratics. Those are parabolas. And you know that that always has an x squared in there. Maybe it's x squared plus 6. Maybe it's a little more complicated, like 5x squared plus 2x plus 1. Just examples. So guess what degree that has? See a pattern? Okay. So now is cubic. That's things that are cubing functions. Maybe they go up, maybe they go down. Something that has a third power. Degree 3. Now we're into ones that maybe you haven't had before, but I bet you see this pattern. Quartic says degree 4, quart, like 4 quarts in a gallon or 4 quarters in a dollar. 4 sections to it. 1, 2, 3, 4. 1, 2, 3, 4. Or 1, 2, 3, 4. So quintic, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. The longer and more complicated the equation, the lumpier your function is. Just some things to kind of consider. All right, we've done a lot with linears, we've done a lot with quadratics. We're gonna keep on quadratics just for a bit, but then in this chapter we're gonna go on to cubic, quartic, quintic. Let's start with some you already know. Math Excel is going to give you some questions that look like this, and it says to write a linear function, a linear equation. You know that means to make a line. But this information may not be given to you the way that you're used to. See how it says f of -2 equals 3? That means you put -2 into your function, you get a 3 back out. You can write that as a point. I put -2 into my function, I get a 3 back out. That's just the point -2, 3. I'm going to do the same thing on the other one. It says I put 2 in my function, I get a 5 back out. So that's the point, 2, 5. If I have graph paper handy, I can graph those two points and go see if I can figure out the equation of this line. Graph my 2 points, trying to make a nice straight line. I'm pretty sure that it is hitting my y-axis at +4, but I might double check that just in case. Because you know, we don't always have graph paper handy. So whenever you write the equation of a line, we always need a slope. You remember how to find slope, right? Rise over run. Rise 2, run 4. Now I have a choice. I am pretty sure that my y-intercept is +4. I can see it on the graph. But again, we don't always have graph paper handy, so there's 2 different ways we can do this to go find your y-intercept. One is to use y equals mx plus b, and one is to use the point slope formula. Just depends on whatever you feel better with. Okay. If I go for y equals mx plus b, I already know my slope value, which is a half, so I'll replace m with a half. Now I need an x and a y value, and I can get that from a point. I have 2 points, so I just pick one. I think I'm going to go with 2, 5, just so I don't have to deal with negatives, but you can use the other point as well. You just can't use the x from one point and a y from another point. So I'm sticking with 2, 5. Be careful about which is x and which is y. I don't know what the b is, and that's my only variable, so then I can solve for it. So I'm going to take my m and x that are multiplied together, and I'm going to multiply them. I'm going to take the half times the 2. And luckily for me, b was 4. So now I can go write my equation. That's one method. The other method is to use point slope form, and I know some of you know this formula and some of you don't. It's a good one to know just in case, so here goes. Sometimes it looks intimidating because you have this x1 and y1. That just means that's the x part of the point you're using and the y part of the point that you're using. So it's x minus x part of the point equals slope times, oh sorry, scratch that, y minus y part of the point equals m times x minus the x part of the point. Said that backwards, sorry. Okay, so y minus the y part of the point that I'm picking, 5. I already knew my slope was a half, and now it's x minus the x part of the point. Doesn't look the same, but if I just do a little distributive property, it's going to look the same really quick. A half times x is a half an x. A half times -2 is -1. Now I just have to move my -5 over so it says y equals. Y equals a half an x, add 5 to a -1, There's your 4. Same thing. Whichever one you like better. Okay, so let's try this one again. No graph this time. Write your points down. Pause your video just for a second. See if you can figure out what it is, and then you can check me. Don't just watch me do it. Go pause the video. Okay, I'll work too. If you're going to use y equals mx plus b, I'll work it over here. If you're doing point slope form, I'll do it on the right. Usually the question is, so how did you get that slope again? Remember, it's y minus y, and then over x minus x. Change in y over change in x. I can pick either point. I'm going to go with the point 1, 2. I just had to add a half to 2, so 2 plus a half is 2.5. Now I can write my equation. Let's go try point slope. And again, I think I'm still going to stick with that point of 1, 2. Be careful if you have a negative x. This one says x minus 1 because it's x minus the x part of the point. If I went with the negative 3, I'd have to write x minus negative 3 or x plus 3. Add 2 to each side. Same answer either way. Hopefully you got the same answer that I did. I don't care that you do it both ways, as long as you pick one way that you feel comfortable with. Just write the equation on the line. You've done that. Okay, so now we get into some things about quadratics. Hopefully some of this you already know. I know that you know a quadratic is a parabola. And the general form of a parabola, you know, is ax squared plus bx plus c. A, B, C, we're going to be using those letters today. But the idea of a quadratic is a cannot be the number 0. So pause for a second, pause the video, and think about why a can't be 0. Did you think of anything good? If a is 0, you're going to get an equation that would say 0x squared plus some kind of a bx plus c. If you have 0 x squareds, do you have any x squareds at all? No. That just makes bx plus c, and now it's not quadratic, now it's a line. So a can be any number, positive, negative, whatever, just can't be a 0. Okay, making sure you know a little vocabulary on your parabolas. I'm pretty sure that you do. Let's see. We know that y-intercepts hit the y-axis. Oops. Like here, there's my y-axis, it's hitting my y-axis here. A vertex is the maximum or the minimum point. A vertex is always on your axis of symmetry. That's that folding line. If you can fold your parabola exactly in half, your axis of symmetry is your fold line. And one really important thing to know, and this may be a good thing to write in your notes, is that your vertex is always on this axis of symmetry. On your fold line, that's where you have that maximum or minimum point. Always. Okay. Now we have a couple of words left, a root and a 0 and an x-intercept. They're all the same thing. X-intercepts are where your parabola crosses your x-axis. Here it's twice. It can cross here at this yellow point, there's an x-intercept, or here. Both of those are x-intercepts. Those very same things, x-intercepts, can also be called roots or zeros. All those words are interchangeable. Just in case. Okay. Few other things that you know, and maybe one thing that's a little new. We'll see how it goes. If your a number is greater than 0, if it's something positive, your parabola opens up. And if a is negative, then it opens down. I think that's something you know. If I have x squared plus 3x plus 1, don't know a lot about it right now, but since a is 1, that x squared has a positive number in front of it, it's going to open up. Negative 2x squared and 4x, if it's negative 2x squared, a negative number in front of the x squared, it's going to open downward. We'll get more specific later. Okay. Probably what you want to write in your notes is about this vertex. We're going to be finding a vertex quite a bit. And the way that you find a vertex is this little formula. Negative b over 2a. Maybe that sounds familiar. It's kind of part of that quadratic formula. It just doesn't have the big square root stuff in there. So we take opposite of b over 2a, and that's what will get you your vertex. So, for example, okay, you're writing this one down, right? 2x squared plus 4x minus 3. If I need to go find the vertex and the axis of symmetry, my axis of symmetry, let's go use this formula, negative b, opposite of b over 2a. You know what a, b, and c are, right? Okay, so to go find this axis of symmetry, I'm going to take opposite of b over 2a. My b is positive 4, so opposite is negative 4. 2 times a is 2. 2 times a, I think I'm getting a negative 1. So that means my fold line, that axis of symmetry, happens at the line y equals negative 1. That's my fold line. I can also tell just from the a number that this parabola is going to open upwards. It's got a positive 2 for a. So not getting a real specific, but I know it's an upwards parabola, and I know where it folds. Now to go a little more specific and get that vertex point, I already know something about this vertex point. I already know the x part of my point. Remember that fold line that was at x equals negative 1? That's the x part of your point. So I've already got the x part of the point as negative 1. Now I just need to figure out the y part of the point. Well, how do you figure the y part of the point? Go put it back in the equation. That's what this says. Go put that number back into your function. Go put your x back into y. If it says y equals, you can find a y value. Put your x into your y equals equation. So I'm going to go put negative 1, because that's x is negative 1. I'm going to put it back in my y equals equation. Y equals 2 times negative 1 squared plus 4 times negative 1 minus 3. Negative 1 squared, positive 1. 2 minus 4 minus 3. 2 minus 4 is negative 2, minus 3 more, negative 5. I know my vertex point, negative 1, negative 5. And it'll open up. For right now, that's all we need. Let's do a few together, and then I'm going to have you guys do a few on your own. So kind of get ready to start pausing, right? Okay. Let's look at these equations. Same thing. We're going to use that negative b over 2a. That will get your axis of symmetry, x equals. Make sure you write x equals because it's a line. And we'll use that x value to figure the y value and get a whole point out of it. Let's go try. So, for axis of symmetry, x equals opposite of b, 2 times a. Hey, x is -1 again. That was nice. So I know that my axis of symmetry is the line, x equals -1. And I already have the x part of my vertex point, 2 for the price of 1. Now let's go find the y part of the point. We'll just put -1 back into your original equation. Two minus 4 is -2, minus 12 more. So I know the vertex is -1, -14. And if I think about it, I also know my parabola goes up because 2 is positive. Okay, let's do the second one. Finding my axis of symmetry first. X equals opposite of B over 2 times A, 2 times -1. Axis of symmetry is at x equals 4, so I'm going to have a folding line on x equals 4. To find the y value, throw that back in your equation. Now you know, right? It's not negative times 4 and then square. You have to square the 4 first. So 4 squared is 16, then make it negative. (32 minus 16 is 16, minus 1 more, I got a 15. So I know that my point is at 4, 15. Once you know your axis of symmetry, you have half of your vertex point anyway. It's kind of nice. Okay, one more. Opposite of B, 2 times A. Ooh, got a fraction. That's okay, they're gonna happen. X equals -1/5. Got my axis. Fold line at the line, x equals -1/5. A little more pain in the butt to go put that into your y equals, but if you need to, go grab your calculator. Oh, you know what? I totally did this wrong and you guys didn't even catch me. What did I do wrong here about -b over 2a? Totally out of order, isn't it? Look, that's your A, that's your B. Were you guys yelling at me through the video to stop this? You should have been. Let's go rewrite it. 2x squared plus 5x plus 9. Now it's in order and I have A, B, and C in the right order. Now let's go for that axis. Okay, opposite of B over 2 times A. Now I got it. Okay, still a fraction, still going to be a pain in the butt, but at least we have the right fraction. Now let's go throw this in our y equals equation to find our vertex. You can put it in the original or the rearranged, it doesn't matter. Probably need a color you can see. Let's see, a negative times a negative is a positive. I just have to square the 5 and square the 4. Okay, let's see, 2 times 25 is 50. I have 50 over 16. I'm thinking I can reduce 50 over 16. 25 over 8. Okay, and I'm going to turn everything into 8 so that I can add and subtract my fractions when they have a common denominator. 9 is 72/8. Okay, 25 minus 50, negative 25, add 72. I'm getting 47/8. Not the best number, but it's done. No, they won't always be like that. Okay, So next slide, there's 2 for you to do. No kidding, take a look at them, pause the video while you work on it, and then we'll see if your answers match my answers. Pause the video. I hope you looked at the first one and realized it had to be a little bit rearranged. You know, so it doesn't get you again. X equals 3 is your axis of symmetry. 322 should be your vertex point. 5/3 should be your axis. X equals 5/3. And 5/3 negative 37/3 is going to be your vertex point. Did you do okay? We're on the downhill slide, we really are. So this last bit is vertex form. So definitely get your pencils. You need to write this vertex form of your equation down. Y equals A times X minus H quantity squared plus K. That A in the front is the A that we're used to with the A squared plus BX plus C. The A is the same. Now you just have your vertex, and you notice where your vertex is. H, K. Remember how we said things on the inside of the parentheses kind of always go a little opposite? Same thing here. I'll show you what I mean. Okay, so write this first one down, please, it would be nice. You have 3 times X plus 9 quantity squared plus 5. This is written in what we call vertex form because you can look at it and you can tell the vertex just by looking at the equation. Your vertex is right here. Remember how things inside the parentheses go opposite of what you think? So when you're writing your vertex, it's not going to be positive 9, it'll be negative 9. But that negative 5 still stays negative 5. And if you really need to, and we need to go write our axis of symmetry, that's your X value. It's right there. It's kind of easy, right? Let's do it again. Let's go find our vertex. So be careful, the one in the parentheses, you have to change the sign. Not positive 7, negative 7. But still a positive 6. And you have your axis of symmetry right there. Okay, last one. Know your vertex? Are you saying it in your head? Positive 2, negative 8. What's that axis of symmetry? Make sure you're writing X equals 2. Okay, now look at that A number and can you help me decide, would this parabola open up or would this parabola open down? That's our A number, right? Parabola opens up. Parabola opens down. Parabola opens down. You have a whole lot of information with really very little work. It's kind of nice. Okay, last little bit to go. This is what's going to show up on your assignment. So here we go. We're going to find the vertex, we're going to find the axis of symmetry, and then we're going to rewrite this thing in vertex form. Don't freak out. Let's go find what we know first. Okay, first we're going to find our vertex and our axis of symmetry. Negative b over 2a, right? And I'm being careful that it's in the right order this time. So x equals, opposite of b would be a positive 6 because I have a negative. 2 times 1, just 2. I think we found our axis of symmetry. Couldn't draw that one. Okay, let's go get our vertex, right? Remember how to get the vertex? You've already got the 3, now you just need to find the y value. Put it back in your y equation. 3 squared minus 6 times 3 plus 12. Ended up with a 3, 3, 3. Okay, so I know I've got my vertex at 3, 3. You also know which way this thing opens, right? Opens positive, upwards. Now we just have to write this out. Remember your formula? Well, you already know the A number. The A number on the original is the A number here as well. This A number is 1. This A number is still 1. Now go fill in your vertex. Do we write x plus 3 or x minus 3? If it's positive, we have to write minus. Don't forget to write that square. Got it. Okay, one more. It's in good order. Let's go find your axis of symmetry. Opposite of B, 2 times A. Thank goodness that was nice. We can use that to find our vertex point. So let's go find vertex point. -2 plus 4 is 2. 2 minus 9, -7. Okay, let's use our formula. We'll fill in every number we know. I'm going to think about my A number first. What's the A number in your original problem? -2. We keep it. X minus h. So think about your vertex point. I have to change the sign on this one, but keep this one the same. Don't forget about that square. Done. Not so bad, right? Okay, you have some homework. It's out of the book, which I know you don't have the book, but there's a picture of it on my Canvas site, which hopefully you're on right now. So do your work, go back through the video if you need to, email me if you have questions, and do a good job, okay? I hope you've been good for the sub. Please be good for the sub. I guess I should have said that. Anyway, thanks guys. See you next week.